I'm really happy to be here today. So my work is focused on predicting psychometric data based on functional connectivity data. So the idea is that if we have a score at a given test, so there is variability in the population for this test, and we try to predict this variability based on variability in functional connectivity. We are interested in many questions that pertain to basic neuroscience, but also for the deployment of brain-based predictive model in the society in general. And these imply the interpretability question in a transparency perspective, which also implies the replicability question. But today I will focus on the question of the generalizability of this model. I mean generalizability in the sense that if we build a model in the British population, for example, would it generalize to the Irish or the German population? And this is an important question because in the field, we currently intensively use several data sets, and these data sets turn out to be dominated by white or European descendant population. So to investigate the question of the generalizability across population minority, we look at the HCP data, so which we have already mentioned before. So this is dominated by white American, but it has a lot of behavioral measurement. And we also look at the ABCD data, which has neuroimaging and behavioral data of thousands of kids or pre-adolescents. And the question we ask is whether we, if we train model in a mixed population and then test the model performance specifically in African American versus match white American, so match for behavioral performance, but we also match for different variables, what would be the difference in the model performance? And what we found in general is that we have larger prediction error in African Americans than in matched white Americans. So you can see it in the Human Connectome project. So for example, here for spatial orientation. So in blue, this is the predictive COD in African American. In green, this is the model performance in white Americans. And in red, this is the difference. And in white, this is a null model based on the assumption of no difference. So we find these significant differences between the two populations for a range of variables in the Human Connectome project, as you can see here. But we also find differences, a similar pattern in the ABCD data set. And these findings were robust to different analytic choice, such as different regression, the confirmed removal model, and different modeling algorithm. So the next question that we ask is, how can we characterize this difference, and how could we anticipate the consequence that they could have? So to address this question, we look at the direction of the prediction error. So here, I will show you what we found in the ABCD data set. In the sake of time, I will focus on that. We find significant overprediction in the African American group compared to the white American group for variables such as rule-breaking behavior and aggressive behavior. By overprediction, I mean that the score were predicted higher than they truly are. And we find a similar pattern for other related variables, such as social problems. So what it means, if we think of the potential consequences for the deployment of such brain-based model, is that these type of information or variable are used in the diagnosis of mental disorders. So if we have this bias, this model bias, this could lead to more false positive for mental disorders in African American population. And so another question then to that came to our mind is, okay, we have this bias. How can we work on it? How can we reduce it? And there is a vast literature on that. In our study, we just try a simple strategy, which is to act on the training data set. So we compare three basically scenario. We had a training in African American only, a training in white American only, and a training in mixed population, which was half African American and half white American. And what we found is that if we train the model in African American only, we have a reduction in the number of behaviors that show, the number of behavioral variables that show a bias against African American. But still, you can see from this plot that there are still many behavioral variables for which the bias against African American is still there. So in some, training only in African American helped to reduce the prediction bias against African American, but still the prediction accuracy were still in favor of white Americans. And we thought of different factors that could explain this result. First, on the brain side, we know that our pre-processing strategies and parameters were optimized on a Y-dominated sample or a data set that are dominated by European ancestry, European descendant population. So I mean, for example, our brain template that we use for the normalization or our functional atlases are typically based on these Y-dominated samples. Also, on the behavioral side, we can question the validity of the psychometric tool for different minorities. So this has been a long-standing question in psychometry, and we know that psychometric tools may have lower validity for specific sociocultural groups because they have been developed in specific sociocultural contexts. So overall, we call for more data collection from non-European descendant or non-white population to learn better representation of minor population for this model. And I think it's important to consider even more minority groups. So for example, here we focus on African American because this is the minority which is the most represented in the US data set. But we can also think, for example, at the Native Americans, which are underrepresented typically in the US data set. Also here in that study, we focus on African Americans, but these are a different population than Africans in Africa, for which at the moment we have basically no data set at all. So our model are not ready to be generalized for Africans in Africa. And there are also subgroups in the currently defined ethnic racial categories that should be considered. So if you look at the data set, we have a category like Asian, in which Chinese and Indian, for example, are mixed. And even for data set that are specific to a country, for example, China has a lot of a specific Chinese data set, but this Chinese data set may also be dominated by a specific population. And we should also think in the future to other minority groups, such as lower social class, who might be also underrepresented in the data set that we use for developing our model. So to conclude, we would like to push for assessing and promoting fairness of future AI application across population. So that was all from my side. Thank you very much for your attention, and I'm looking forward to further discussion.
Thank you very much for this interesting presentation. Maybe if you stop sharing the screen, then